Hello, and welcome to the IEEE Spectrum Online presentation, WAN Architectures for a Cloud-Native World. I'm Dexter Johnson, and I will be moderating today's presentation. Before we start our presentation, I would like to mention a few housekeeping items. For those of you using Chrome or Edge browsers, if you have Flash blocked, please click on the play button on the media player. If for any reason you have some difficulty seeing the slides or can't see the presentation or have some issues with your audio, the best thing to do is just refresh your browser. This will fix just about any issue you may be having. For those of you who want to know if this session will be archived, the answer is yes, it will be archived and will be available for review within about 24 hours. And once the archived webinar is available, a notification email will be sent to all the registrants, and that includes everyone here today. In addition to our presentation today, we'll have a Q&A session at the end, and so we encourage questions from the audience. So as your questions occur to you, please type them in the Q&A box provided on your computer screen and hit the submit button. You don't have to wait until the end of the presentation to begin submitting your questions. If you're looking for the PDH certificate code, this will be given in a slide at the end of the presentation. As you look over your screen, you should also see buttons that allow you to enlarge the slides if you so desire. And about volume control, if you're listening to the audio over your computer speakers and you need to adjust the volume, you may need to adjust the volume on your computer itself. There are some additional widgets at the bottom of the slide that will improve your viewing experience. And you should see today's presentation and a link for the PDH certificate code form. Now I would like to introduce our speaker today. That is Amit Naik. Amit is a product marketer and industry expert with more than 20 years of experience in network services and information security. He's held senior solution engineering and product leadership roles for several leading vendors. Amit has advised multiple global service providers and financial service organizations on best practices in enterprise networks and in security. And with that, I'll turn it over to you, Amit, if you'd like to begin.
Thank you, Dexter. And thanks, everyone, for joining our session today on WAN architectures. So the topic we want to examine today is the evolution of WAN, right? Evolution of WAN area networks. So wide area networks have been around for a long time. And predominantly, they've played this very important role in enterprise networks. And there's a few good reasons for that, right? So as business functions and processes moved to more digital online, we saw an architecture that emerged, which was more built around the client-server model, right? So we had applications which were essentially had a back end and a front end, and the back end would live in a data center somewhere that an organization would maintain. And then the front end would typically be on your laptop and then eventually mobile devices and tablets, right, through which folks could access these applications. And what this world gave us is what we call the castle and moat model of enterprise networks and enterprise WANs. And this is basically where you built this completely isolated wide area network that was private, it was secure, it had a strong perimeter around it, and like a moat. And there's WAN architectures that evolved to work well in this world, and we'll take a look at those. But we saw a couple shifts happen over the past few years, right? So the first shift that happened is the adoption of the cloud, right? And when I say cloud, I mean more broadly. I mean the public cloud services that you know of, like AWS and Azure, Microsoft Azure and Google Cloud, but also software as a service applications that have become very, very business critical these days. Ranging from customer relationship management software like Salesforce or HR software like Workday, right? So all these software, most of the software applications we use in business today, we're accessing via a web browser, right? So that was a big shift. And that forced a little bit of a shift in WAN architectures because the perimeter, the moat that you had around your network, it kind of started to dissolve, right? because you had to sort of open these connections out to the public cloud, out to the internet, and that perimeter started to get a little bit ill-defined. And that led to some changes like software-defined WANs and virtualizing some capabilities, moving some functions into the cloud. So that was one major shift that happened. The second major shift that we saw is happening right now. And this is the shift where the internet is now essentially becoming the new corporate network. And it's a bold claim, but if you think about the way a lot of us have been working in the past year, right? If you've ever got on a meeting on Zoom, guess what? Zoom is delivered over the internet. So you were using the internet as your network to do business. And this is creating some additional challenges and possibilities and opportunities, and it's shifting the whole WAN model to something you might have heard about called network as a service. And then I'm sure you might have heard of the term zero trust, right? So a unified network as a service and zero trust architecture is what we're really starting to see more and more of. And we're going to talk about kind of what this looks like, and how you can embrace this within your organizations as well, and how you can apply this in practice. So in order to do that, let's take a look at this fictitious company. So introducing Acme Corporation, right? And Acme is, a typical company that is doing business. They're a retail company. They have about 100 plus locations within the United States, and about 50 plus locations outside the United States. So they're global in nature. And if you wind back 10 years or even a little bit further back, this is what Acme's WAN environment would really look like, right? So you have, of course, the headquarters, the main locations. There may be a couple of them. And most of the applications would live inside the data centers. And the data centers here in this case are private data centers, so they're physically owned and managed by Acme. And there's a couple of them that exist. So there's one on the West Coast, there's one on the East Coast, and for disaster recovery purposes. And they're interconnected via fiber or via VPLS services. And that gives the east-west connectivity between these data centers, right? And then you also have all of the branch offices that exist across the globe. You also have retail stores and locations. And, the retail industry is going through its own transformations, and it's starting to see a fundamental shift as well, where, retail locations are less points of doing business, more of experience centers, et cetera. But let's assume they had, 10 years ago, they had retail locations which were business critical, which were important to revenue. And if you lose, some of these locations, if you lost network connectivity, you couldn't transact. So, availability and performance and reliability, all these things are very, very business critical issues for these retail store locations. And what most organizations typically did at the time was went out to a carrier and purchased, put on an RFP or purchased an MPLS service. MPLS, as you know, stands for multi-protocol label switching. It's a way to build private networks that where you can route your own local area networks and establish WAN connectivity back to your data centers. And these MPLS services were typically offered by large carriers, right, that exist over the world. Some of them offer only local regions. Some of them offer global services, right, where they can connect your locations across the world as well. And this MPLS network basically gave you very, very tight, reliable connectivity back to your data centers, right? And in the client-server world, this was great. This is fantastic. But then you had the internet. And the internet, of course, is a critical part of any wide area architecture. So what you typically see is these data center locations would have egress points to the internet. And that would enable connectivity for data center servers to install software updates, right? But also for users that are sitting in these locations to access the internet. But that also meant that if you had a user that, let's say my data center on the West Coast is in San Jose, and I have a user sitting in an office in Austin, Texas, that traffic has to now travel the MPLS backbone and MPLS network, come back to the data center in San Jose, and then get out to the internet. Right? So, slightly less than optimal architecture. And but if majority of your apps were at the data center, this was not that big a problem. Your performance surfing, some e-commerce sites or some consumer websites wouldn't be as great, but that was not really a big deal because those were not business critical applications. Right? And then along with that, you also had I talked about the security perimeter earlier, right? So each data center location at the internet egress would have a whole stack of appliances that would not only give you the connectivity, like the routing and switching appliances, right? That would give you the connectivity back out to the internet. But you'd also have additional technologies in that stack, technologies like WAN optimization, right? So we've seen WAN optimization, heavily adopted by organizations to help some of the remote sites or help connectivity, help optimize app performance between remote locations. And WAN optimizers use a combination of techniques like compressing network payloads, terminating sessions locally, and optimizing MTU on some of these packets. And that's how, and you're using a variety of tricks like caching, et cetera, to reduce the dependence and improve application performance over the network. Then you also had technologies like secure web gateways, and that would control the ability of your users to connect to sites or websites or other applications that are sitting out on the internet. And why would you want to do that? Well, if you have a protected device that's sitting inside the protected perimeter, you want to be able to block known malware sites. You want to be able to block things that are not in line with your corporate policy, acceptable use policy on the network. And that's why we had secure web gateways, right, that give you a good control point to do that. We also had technologies like web application firewall. So if you had external facing applications that were open to the internet, this would protect you against web application threats. Also had next-gen firewall, which would give you application-aware and identity-aware security for your internet exit points. And then you had some DDoS protection, right? Any connection or service that's open to the internet has a high likelihood of getting hit with DDoS. And it's not a question of if, but it's a question of when and how much, right? Any resource that's open on the internet is always a target. And depending on what applications they're running, you may be vulnerable to DDoS attacks. And then you also had a few other applications like appliances like load balancers that'll help you optimize app performance across. So this stack basically was kind of discrete, and it consisted of appliances. Eventually, the appliances went virtual, but there were still discrete appliances that you had to manage and scale. And there's some pros and cons to this approach, right? So the pros are that this is an architecture that a lot of us grew up with and we understand and we feel comfortable with it, right? You have two definite exit points to the internet. You have points you can control. It's also not a great thing because those two have the potential to become choke points, right? As your needs change. But let's think about that a little bit later. So it's a familiar architecture that we all know. You can potentially manage, by having these two discrete internet exits, you can manage policy centrally so that anybody in any offices across the globe, you can control the security policies that you apply to them. Right? So there's some advantages there. The MPLS network is fairly uniform. You may have purchase it from the same vendor or maybe a couple different vendors. So you have some performance guarantees and reliability guarantees around that as well, right? So what are some of the cons of this model? So the cons of this model is, MPLS as a WAN architecture can get really expensive really quickly. We've seen, prices start to trend downwards over the years, but it's still a fairly expensive way to do things. And, it's for a reason, right? So MPLS gives you some really good SLAs, gives you reliability, gives you multiple classes of service that you can carry over the network. So if you have a WAN that is running video calls, voice calls, as well as payment transactions, you can prioritize those applications accordingly. So there's some benefits to that, right? But it's a fairly expensive way to run it. But the bigger issue with MPLS is it locks you in. It locks you into fixed price contracts for typically 3 years. If you need to make changes, if you need to decommission some offices, or decommission some stores, depending on your business needs, right? You still end up having to pay for what you don't need because you're locked into this contract. So it lowers your business agility overall. And then the other big problem that your users face is the latency penalties. Because in this model, if you are sitting in an office, let's say in Europe, you may still have to come back to a data center in New York in order to exit to the internet, right? So that's an unnecessary network penalty that you're incurring. If you're sitting in Europe, let's say you're trying to shop somewhere online, there may be a location right in Europe that serving that application. But in this model, your traffic is going to come back out to New York across the Atlantic, and then get out to the internet, and that leads to a less than ideal application experience. And 10 years ago, maybe we were not so dependent on web-based apps. A lot of the applications lived within the data centers, at least the business-critical ones. So this was maybe an acceptable way of doing things, and trade-off that a lot of organizations were willing to make. Right? So what's happened in the time between then and now? So there have been a few fundamental shifts in the industry, right? So if you look at today, you still have data centers in some cases, right? In some cases, you still have a few applications running on them, and they still do exist. But a lot of applications have moved to public cloud services. And if they haven't moved there, then there's a lot of applications that have been entirely born in public cloud services. They were built natively in AWS or Google Cloud or Azure, and that's where they've always run. And many of these are business-critical applications for an organization, right? So that's one major shift that's happened. The second major shift is the adoption of SaaS. And software as a service is typically, if you've purchased any new software in the last 3, 4, 5 years, chances are it is delivered over the web as a service. And when I say delivered over the web, it's essentially delivered over the internet, right? So you are dependent on the internet connection to go access this application. So the internet links that we talked about earlier are that much more important in this whole world. And then the third major shift that's happened in the last 5 years, and nowhere has this been more acute than what we saw in the last year and a half, which is remote workers, right? So last year and a half, we were very abruptly forced, many of us, not all of us, but many of us were very abruptly forced to work out of homes. And the office, you couldn't even go into most offices. So everybody essentially became a remote user, right? And typically, how do remote users connect back to these resources? Well, they connect over the internet directly, or they connect over a VPN back into your data center, and then go back, get all the security policies applied, and then get back out to the internet. So these are the two models that we see out there for today, based on for remote users, right? And remote work is going to become a matter of fact for many organizations in the near future. And we see that, we see some offices starting to open right now, and some of them are shutting down again because of the recent surge. But I think it's safe to assume that we need to plan, as network architects, we need to plan for a hybrid work model in the future. So what happens in this world? So one of the ways we've adapted to this change is through the adoption of something called software-defined WAN, right? So software-defined WAN essentially gives us a few different options to re-architect or to simplify the management of this environment, right? So software-defined WAN essentially is an edge technology. So if you look at these little orange icons at each of the locations, it's an appliance, and it's a software appliance and a hardware appliance that runs at each of these locations. And this appliance opens up some possibilities for network architects and WAN architects to simplify and reduce costs potentially. Right. So what do I mean by that? So for example, if you have an MPLS service in a store, and let's say you need to add 10 new stores in a particular region, you may not need to add MPLS services to that for those new locations. You may go out to some local ISP and simply purchase a broadband internet connection. And that internet connection will, these appliances will give you the ability to create secure tunnels and secure overlays over that internet connection back to your data center. So software-defined WAN, it's in various stages of adoption across many organizations. And it has the benefits of reducing the operational overhead of managing the complexity of a growing network. So if you need to add sites, if you need to be more agile, it gives you some other options than going back to your MPLS vendor and renegotiating the contract or trying to get out of contracts. So it gives you some of that business agility back. It also gives you, a single administration console where you can manage all these services and you can simplify the way you're managing your WAN. Right? But so what's the catch here? What's the problem? The catch with SD-WAN is that it doesn't fundamentally change the hub and spoke model around with the way hub and spoke model is and the way WANs are built, right? So if you look 10, 15 years ago, we built it around the hub and spoke model because the data centers were in a couple discrete locations and the users were all over, and that model worked well for us, right? And SD-WAN actually gives us some alternatives and some options, but typically what forces traffic back to the data centers is the need for security governance, right? So let's say I have my remote users. Let's say I'm an organization with 5,000 employees, and I want to enforce a consistent security policy on what websites all my employees are allowed to access and are not allowed to access. That's kind of hard to do if they are all around the world or they're working out of home, right? And you can accomplish that by forcing them down a VPN, come back to the data center, then go out to the internet. But that is suboptimal, right? That's going to incur latency penalties. And all the security services that you typically need are not available in every location, right? They're not always there. And it doesn't fundamentally get you away from sort of having to live with some legacy MPLS connectivity, right? So it solves some problems. It solves the administrative problem. It gives you some business agility back. It doesn't fundamentally solve the architectural issue that most WANs are stuck with right now. And if you look at this diagram here, right? So with the adoption of SD-WAN, your remote users don't necessarily have a great experience because they still have to backhaul to some central location where the VPN gateway is placed, and that may be a long path, and they don't have the greatest experience, right? If you have users that are in locations that are only served by the internet, the thing about the internet is it's everywhere, right? So it can get you it's easy to get connectivity to the internet in most parts of the world, right? And some it's not as easy as we think or we hope, but it's easy to get that connectivity. And once you're on the internet, you can get using SD-WAN, you can get a connection back to your data center or to cloud services and establish that connectivity. But at that point, you're not really able to control the performance because you're going over this last mile network, this middle mile network, that is the public internet. And on a good day when everything's working well, you'll have a great experience. A day later, if something's going wrong on the internet or if there's some congestion in certain parts of the world, you may have a not so great experience. Right? And these are some of the problems that a lot of organizations are still contending with in the world of SD-WAN. So what should Acme Corp do in this situation, right? So what does the future hold for Acme Corp? So as as the future of work sort of plays out, we've seen the acceleration of remote work, right? So folks who are able to work from home, mostly digital workers, knowledge workers, doing computer-based work, they're able to work from home. And that's what they're going to continue to do for at least the next little while until the pandemic sort of starts to settle down some more, right? So what this does is essentially makes the internet your new WAN, your new corporate network. And in this model, the good news is the internet is everywhere, right? So you're able to leverage it, and most people can find a way to get on the internet. As we saw last year, we didn't have to really try very hard to get connectivity. We had to change some of the applications we're using, right? We shifted to more to web-based applications, internet-based apps, but it didn't change. I don't think we really had an issue getting connectivity back to the internet. So this has given rise to what we call a slew of zero trust services, where you have network connectivity that's interconnecting all of your locations, all of your users, all of your data centers, offices, factories. You have the connectivity piece. And then you have security services that are actually, they exist in the cloud natively. So there is no one single appliance that you have to funnel everything back through. These services are available in the cloud. They're available in the network, and they can be turned on, as needed. And this model has a lot of advantages, right? So this gives you the maximum business agility. So if you need to, shut down offices, shut down store locations, open new locations, shift your users, it gives you the ability to do that. It makes sure that you have the strongest security posture, because now you can apply security policies consistently, regardless of where the users are, right? So if the future is hybrid, where people come in 3 days a week, work from home 2 days a week, you can make sure that they have the same security policies when they're at home and when they're in the office. Reduces the total cost of ownership, because you're not dealing with fixed price contracts, a 3-year lock-in terms. And because your security services are everywhere, you no longer have to backhaul traffic to a central data center location. And that makes sure that your application always stays on the most optimal path. Application traffic stays on the most optimal path, and your users have a better experience, right? So if let's say you're using Office 365 in your organization, right? If you read the deployment best practices that Microsoft puts out, they'll always recommend that you get out to the internet as quickly as possible and not backhaul traffic, right? So in this model, you can actually comply with that, actually implement that, and make sure the users have a better experience. The challenges of what are the cons of all of this? So I painted a sort of a model here that looks good and sounds good. The challenge is this isn't a single provider, right? So no single provider can solve for all of the use cases 100% of the time. And then stitching together point solutions creates more problems. So let's say you go out and buy a secure web gateway service from vendor A, right? And that's what you've been using, you're really comfortable with it, and they have a service A. And then you need a intrusion prevention service from vendor B. You need a DDoS mitigation service from vendor C. And if you're consuming all of these from the cloud, you have the service chaining problem, right? How do you get the traffic to kind of hit all of these elements so that you're applying all the security functions, but you're doing it in a consistent way, right? So that's one of the challenges that are starting to emerge as some of these new WAN architectures take hold. So how do you solve this, right? So what's the right answer for this? But before we jump into that, I want to throw up a quick poll and understand from our audience, which security technologies do you currently use in your organization?
Thanks, Amit. I just want to remind everyone in the audience, don't use your chat to answer the question. Use your screen and choose one of the options here. Let's see. Is it... Yeah, okay. So you choose, it's a multi-choice. So which of these technologies do you currently use in your organization? MPLS WAN, IPsec VPN for remote access, SD-WAN, single cloud provider, multiple cloud providers, or zero trust network access. So if you could choose one of those, don't chat back your answer, just do it on the screen and choose one of those, and we'll push up these results. Wow. So it looks pretty clear indication there.
Yeah. So thanks for the response, and we got a response from a few people, and it looks like IPsec VPN is still a dominant thing in a lot of organizations, right? And the other technologies are sort of in various stages of deployment, and this is not unlike what we see out there, which is you're still kind of dealing with trying to find secure ways for employees to access business applications from wherever they are. So what's another approach to this? So I want to spend the next little while talking a little bit about Cloudflare and something we call Magic WAN. And I'll explain a little bit as to what this means. But before we jump into that, I want to share a little bit of background information about Cloudflare. So some of you may have heard of Cloudflare. You may know about us. But Cloudflare is we operate a global network platform with just massive scale. So we are serving about 25 million internet properties, including SaaS applications, which is a significant part of the internet. And we operate a global network which has about 67 terabits per second of network capacity worldwide. We have what we call data centers in 200 plus cities across the globe. So our goal is to be as close to the what we call the users, or we call them eyeballs, as close to the users as possible. And in the process of delivering applications across this global platform, we see a lot of security threats as well, right? So on a typical day, if you look at the number of threats blocked, it can easily range in the 70 billion range. And we're close to 99% of the users in the world within 100 milliseconds. And Cloudflare has this global network platform through which we've been delivering services. So another way, we started thinking about this. It's like, what if we could leverage this platform to simplify WAN architectures as well as security for a lot of organizations, right? And that's essentially what we're doing here, right? We're talking about Cloudflare's network as an extension of the enterprise network. So most of our customers have some kind of a WAN environment already, right? And then by attaching that to a Cloudflare data center, Cloudflare location, wherever they are, we can bring the power of the Cloudflare platform to our customers' network and the WAN architectures and simplify it, right? So what does this really look like? So the way we think about WANs is a little bit different. Think of it as sources and destinations. So sources and destinations might be your devices, right? Your managed devices. It could be users. It could be your own employees, or it could be customers to whom you deliver certain applications if you're a digital company, right? Sources and destinations are the apps themselves. And the apps may live in a private data center, or they may live in the public cloud, or they may live somewhere out on the internet, right? The internet itself is a source and destination. A big chunk of it which is running on the Cloudflare platform, including SaaS applications. Then you have the public clouds like AWS and Google Cloud and Azure. You have physical office locations, and then the legacy data centers, right? And some of you might wonder, well, physical offices, are they going away? Or are they what's the situation there, right? So when we talk about offices, it's more a general sense, and not just offices where people work, but office could also be a clinic. It could also be a factory. It could also be a service delivery point, right? So it's more office in a more general sense. So these are the sources and destinations that you really need to interconnect. And at the bottom, you have the services that you typically need in an enterprise WAN. Right, so you want services like network firewalling, right? DDoS protection. You want WAN traffic acceleration. You need a flexible, agile WAN. You need a secure web gateway. You need zero trust network access, right? So there are some network services here, zero trust services here. If you're delivering applications out externally to customers, you may need a CDN. You'll need a web application firewall. You'll need protection against bot attacks. You'll need load balancing as well, right? So these are all the services that exist already in the Cloudflare network. And in the middle, interconnecting these, you have what we call on-ramps. So instead of thinking of legacy network technologies as A or B choices, our view is, well, think of them as on-ramps, right? So if you have an existing SD-WAN network or an existing MPLS network, that's just an on-ramp to get you onto one of these services, right? And that's going to help you interconnect them. If you have a remote user, then there's a roaming agent on the managed endpoint, a device that can get you connected back into this network, right? If you have an existing network or if you have a cloud service, you can interconnect to it via an IPsec tunnel or a GRE tunnel. Or in some cases, you can even establish dedicated connections through data centers if you're co-located in the same facility or nearby, or able to get a fiber connection, right? So this model really helps you rethink of their WAN as a more flexible network, right? Where you're not sort of completely repurposing and replacing everything you have, but you're integrating all of these pieces through these different on-ramps or connectivity methods, right? And one of the benefits that Magic WAN offers from a Cloudflare perspective is all these services that you typically need, they're available in every data center in every location, and they're delivered closest to where the users are. So let's say, if I'm working in my home office in San Francisco today, and I have a certain set of security policies apply, right? Those policies are being applied out of the nearest data center here in San Francisco. But let's say tomorrow I get on a plane and go to New York. Those same security policies will get applied out of the data center in New York. So me as a user don't notice any difference, right? My traffic is not forcibly backhauled to San Francisco to apply those same policies. Those policies are available at the data center in New York as well. So as a user, I don't notice my experience change dramatically, right? So that gives you sort of the consistent experience for users, and you can really sort of rethink the way you architect your WAN, combine a lot of different technologies, and integrate all the different pieces. This also makes it easier if you're dealing with acquisitions, if you're dealing with organizational changes, and integrating sort of legacy systems into newer systems. You don't have to think of them as separate islands and just nail them together using tunnels. You can integrate them more flexibly, and then still apply the universal uniform services layer across the entire network. So that was a quick introduction to Magic WAN, how WAN architectures are changing with the shift to the cloud, and hopefully you found this useful. If you need more information about this, there's a great white paper on our website about transforming enterprise network architectures. You can access it at this URL here, www.cloudflare.com/magic-WAN. And there's a link there to read this. You can also contact me directly. My email address is here. Or you can reach out to anybody at Cloudflare as well if you need more information. So with that, we'll pause and take questions.
All right, great. Thank you, Amit. I think I'm going to just put that contact details back up there for people who are writing this down. So prepared some questions. So cloud providers have their own backbone networks. How does this compare to using a traditional WAN?
So that's a really great question. So cloud providers, as you know, have multiple locations in multiple regions across the globe. And they've been building out their own backbone networks to facilitate some of the east-west traffic and east-west communication that happens between apps, right? If your applications are entirely contained within the cloud service, this is a really good option. But there's a couple of things to think about here, right? So one is writing that backbone it's not free. There's a cost to it, right? So there's definitely a charge involved. And what's interesting about cloud services is as opposed to traditional WANs, with traditional WANs, you typically pay by the size of the pipe. For cloud services, you typically pay by the volume, right? The buckets that you just buckets of data that you send back and forth. So that can change your cost equation a little bit. The other thing to keep in mind is multi-cloud. So not all the cloud providers are as multi-cloud friendly. So if you have multiple cloud platforms or you're integrating, let's say you started off in AWS and then built some other applications at GCP and Google Cloud, you may have to think about how you're going to connect those together, right? And traditional WANs definitely will help you do that. Magic WAN will help you do that. And that's something to keep in mind, right? And for those use cases, you have to exit the cloud provider's network and go on to something else. And there's a couple issues to think about when you're thinking of using provider's own backbone versus traditional WAN.
Okay, let's go on to another question. What's the future of the WAN with the rise in remote work and SAS?
So that's a really great question. So we've seen a lot of conversations about the future of work and work going hybrid in the near future. I personally feel like even though users are sort of shifting and dispersing, there's always going to be a need for WAN connectivity, right? Offices are not going away completely. They're transforming. They're turning into collaboration spaces. They're not going away. And then there are a lot of service delivery sites, factories, clinics, movie studios, a lot of locations that need that connectivity, right? And it needs that connectivity that only a WAN can provide. So I don't think, we're converging to using more and more of the internet as a corporate network, but you still need to think about how we're going to connect all of the sites together.
Okay, great. So I encourage some more questions. Feel free to, type in your questions. We have a few minutes here. So another question, does Zero Trust services incur more delays, and how secure are they?
So the question is, do Zero Trust services incur more delays, and how secure are they, right? So Zero Trust services, if they're done right, they shouldn't add any noticeable delay to the application performance. The couple of factors that are likely to add delay to Zero Trust services is if you're chaining functions through different discrete blocks, right? So let's say you have one function to do DDoS protection, and that sits in data center A, and then you need to do malware scanning, which sits in data center B, and you have to get traffic from data center A to B over some network. And in some cases, the vendor might be able to do this transparently behind the scenes, right? You don't see it, but that does add performance penalties. So there's advantages in doing single pass inspection, where you have all the services that are uniformly available in every location, right? So once you start inspecting the traffic, you can apply all the policies right there and minimize the any latency additional latency from these services. So that's one way to optimize Zero Trust services. How secure are they? I have to say, they're very secure, right? Same, if not better, security than what you would get from a traditional on-premise appliance. And the reason I say better in some cases is by virtue of being a cloud service, all the threat intelligence feeds, all the security knowledge, all of the known vulnerabilities, right? All that intelligence gets immediately applied to the security policies. So you don't have to wait for a daily update. You don't have to wait to get an advisory and then do software upgrades. All of that intelligence is available to you immediately.
Okay, great. One question here. This may wrap it up for us. Doesn't SD-WAN solve a lot of cloud connectivity issues?
SD-WAN has definitely simplified the management of WAN networks and made it a little bit simpler to do things like, if you're in a branch office and you have a heavily used app that's sitting in an AWS region, you could potentially set up a direct connection from that branch office back to that AWS region over IPsec, to that VPC over IPsec, and simplify traffic routing that way, right? But the problem this doesn't solve is where are you going to apply security to that flow, right? So now you have to potentially stick a virtual firewall in your VPC in AWS, run the traffic through there, and you still have to, and you may have a different solution for other branch locations, and you end up with sort of a non-homogeneous security model where you're doing, exceptions for some of these flows, right? So while it solves the some of the administrative problems and management problems, it doesn't fundamentally move away from the hub and spoke model that we've been living with.
Okay. I guess we'll wrap it up there. I want to be sure to push out this PDH certificate code for those of you who are getting credits for today's webinar. So as I indicated earlier, this session will be archived in about 24 hours, and once the archived webinar is available, a notification email will be sent to all the registrants, and that includes everyone here today. I'd like to thank Amit for making this such an informative presentation, our sponsor, and thank you, our audience, for participating in today's session. We hope you found today's event valuable and will return for future IEEE Spectrum Online webcasts. Thank you.
Thank you, Dexter, and thank you for having me.
Thank you.